Put simply, linear perspective is a method of drawing by which an artist creates the illusion of three-dimensional space on a two-dimensional surface. The image on the left is a box drawn without perspective, also known as plan view, and appears completely flat, having only length and width. The box on the right, however, appears to sit in 3D space, having height, width, and depth. This is because it is drawn in perspective. The founding principle of linear perspective is that the farther away something is, the smaller it appears. Conversely, the closer an object is, the larger it appears. This concept is illustrated in these figures, showing a two-dimensional side plan drawn without perspective next to the perspective view seen by the viewer. A common analogy used to explain the principles of perspective is the train track, continuing infinitely along the level land until the distant plane appears to converge with the sky on a long, even line. This is the horizon, or horizon line, which we will later refer to as the HL, as it is the commonly accepted shorthand. It is also, for the time being, our eye line or eye level. More on that in a second. Standing in the center of this railroad that continues on into the horizon until it is lost from sight, we notice that the two sides of the track, while parallel in reality, appear to converge and meet at a single point. This is the vanishing point, otherwise known as the VP. This particular vanishing point in the center of our vision, which the horizon line cuts through, is our one-point perspective vanishing point. The side plane of all objects which are parallel to our vision, in this case the rails of the train tracks, will converge to this single point, thus one-point perspective. Meanwhile, the front edge of the planks along the track, which are perfectly perpendicular to ourselves, do not diminish to a VP. They are a true horizontal, and this behavior is true of all front planes which are perpendicular to us. Basically, what you need to understand is that objects only diminish as they go further back in depth. Remember our founding principle. So, if we have an object whose front-facing plane is perfectly perpendicular to us, then the entire width of its front-facing plane is occupying the same depth, and thus does not converge to any point. The lines simply go on left and right for infinity, and this behavior is the same for a height that is perfectly parallel to us. Its lines go up and down infinitely. Going back now to our founding principle, notice how the distant planks seem smaller and closer together, while the closer planks seem larger and farther apart, while in reality they are all the same size and of equal distance to each other. Keep this behavior in mind, but if you don't quite get it, worry not, as we'll be covering formally measured depth in later videos. Consider now that you decided to take a seat in the middle of these train tracks. The track climbs to a height level with your eyes, whereas before, in the standing position, we saw clearly the broadness of the planks and the two rails converging to our vanishing point seemed long and narrow. Now, in our seated position, we see far less of the top plane of the planks, and the convergence of the rails seem far less extreme. This effect is caused because when we sat down, we decreased the height of our eye level and brought the train tracks much closer to it than the eye level of our standing height. Imagine, if you would, that directly in the center of your vision there was a long horizontal beam emitting from your eye. This is your eye level. For objects that are more or less parallel to the ground plane, if they are below this dividing line, we will see the top plane, and the further down they are below the eye line, the more of that top plane we will see. On the other hand, we will see the bottom planes of objects that are above our eye line. Take a minute to examine your surroundings and see this effect for yourself. You will see that when you are above an object, its sides will converge up to the center of your vision, and vice versa for objects which you are below. Next, we'll return back to our standing position, though now we'll turn our heads to the left so that the train tracks are no longer in the center of our vision, but off to the right. I hope you'll see now that while the rails converge to a single vanishing point, the planks along the track converge in the opposite direction, far off and to the left. This is because as we turned our head away to an angle on our left, the planks are no longer parallel to our vision. Thus, the rail tracks do not converge to the one-point vanishing point that is always at the center of our vision, and the planks are no longer perfectly straight lines. Instead, if we consider where the plank inserts into the track as the corner of a box, we notice the side plane to the right of the corner and all edges parallel to it converge to a common vanishing point to the right of our center of vision, and all those to the left of the corner converge to a common vanishing point on the left. This is the essence of two-point perspective. Any object which its front plane is not flush to you will converge at the top and bottom to a vanishing point away from the one-point perspective vanishing point at the center of our vision, the side plane converging in the opposite direction. The degree of their convergence, or the rate/speed at which these lines diminish, depends on what angle the front plane is turned away from the viewer. To further clarify, let's bring this out of a perspective view and put it into a planned top view so we can see what's really going on. We'll look at this in two ways. Firstly, that we are at the center of the universe, so to speak, and the rail is moving down to the right at an angle, or that the rail is perfectly straight and we, the viewer, are looking away from it at an angle to our left, both of which result in the same perspective view which we discussed earlier. Finally, back to our original position, consider that someone placed a box in the middle of the train track turned away slightly. We approach it, and as it is shorter than us, look down upon it, our heads tilted. We notice, like before, that because the edges of the top plane of the box aren't flush to us, they converge in opposite directions off into the distance. However, the direction they converge is not to the eye line now, but to the horizon line. Yes, because we've changed our angle of our vision to look down to the ground, the land or ground plane is no longer parallel to our vision. We've divorced our eye line or eye level from our horizon line. And so now, the horizon line is no longer in our frame, though the top planes of our box still converge to points on the HL. As a brief aside, you can still have the horizon line in your three-point composition or frame. I just really wanted to emphasize here the separation of eye level and horizon line in three-point perspective. And again, if you're confused with any of this, I'd ask you to just trust me for now and go along with me. I promise later on, once we go over formally measured three-point perspective, you'll get a very thorough understanding of it. For now, I'm just introducing these concepts so they can sit in the back of your mind. Anyway, moving on, we'll also see when we examine the side planes that the edges all diminish down to one common point beneath the Earth on our center of vision line. This is three-point perspective. So, the length and depth of the box converge to points on the horizon line, while the height diminishes to a point below your center of vision, known as our vertical vanishing point. Additionally, if we held the box up above us and looked up to it, we would find now that the height converges to a common point above our center of vision line. And that concludes this introductory lesson on the principles of linear perspective and point perspective. I hope you'll join me in the next lesson where we're going to take these concepts I introduced and expand on them by introducing you to the complete formal perspective setup. And also we'll plot out a top inside plan view and then bring that into a perspective view so that you can really see what's going on with these concepts. It's really going to change the way you think about 3D space. See you next time.